Hello, my name is Dennis Michael. I work for the Environmental Protection Agency Office of Air Quality Planning and Standards. This video will illustrate a calibration of a tipping bucket rainfall or precipitation sensor. First, let's talk about why we need to measure precipitation at monitoring stations. Rainfall is defined as the total amount of precipitation which reaches the ground in a stated period, and is expressed as the depth to which it would cover a horizontal projection of the Earth's surface if there was no loss by evaporation or runoff, and if any part of the precipitation fallen as snow or ice were melted. Rainfall is an important parameter because it is used in wet deposition modeling. An additional benefit for precipitation data is to understand the reactivity of the atmosphere. Usually after a rainfall event, air pollution is removed from the atmosphere. Therefore, air pollution levels should be relatively low after rainfall is recorded. Before we get going, let's define what we mean by a calibration. EPA defines a calibration as a comparison to a measurement standard, instrument, or item with a standard or instrument of higher accuracy to detect and quantify inaccuracies and to report and eliminate those inaccuracies by adjustment. So you can see there are really two parts to this process. Primarily the measuring of conformance, and secondly the adjustment to that conformance. What this translates to is testing and adjusting the instrument to see if it meets our standards. For a precipitation gauge, this means imitating a rainfall event. This is performed by introducing a known amount of water into the gauge over a period of time and recording the output from that gauge. Calibration of meteorological systems always takes at least two people to perform. The reason is simple. While one person is performing the test on the instrument, another person must record the responses. This sensor is an R.M. Young Corporation Model 52202 tipping bucket rain gauge. It is attached to the railing of the top of the monitoring shelter. Note that the opening of the rain gauge has a conical shape. The opening is sometimes known as the pan or the funnel of the gauge. The funnel is designed so that strong winds will not allow rain captured in the funnel to escape. Once the rain enters the funnel, all rainfall will run down to the opening and enter the measurement portion of the gauge. At this time, the technician will remove the funnel and inspect the tipping bucket. There are two important issues to note when inspecting the tipping mechanism. First, is there any debris that could cause the mechanism to not work properly or make the tipping mechanism stick? The second item to note, are there any insects or spiders that inhabit the inside of the gauge? If so, these must be removed and the tipping mechanism cleaned. After the technician has cleaned the inside of the gauge, be sure to reinstall the funnel and housing. We are now ready to perform the calibration of the gauge. As stated earlier, the calibration consists of introducing a known amount of water into the gauge over a known period of time and recording the output from the gauge. We have chosen a 50 milliliter burette. We will attach the burette in a fashion so that it will allow a known amount of water to be introduced into the gauge. At this time, let's record the make, model, serial number of the rain gauge sensor. You will need to calculate how many milliliters of water translate into millimeters or inches of rainfall. This information is in the manufacturer's operation manual. Once you have decided on how much water to introduce into the gauge, these will be the reference values for the calibration. The holding stand is now attached so that the burette can be positioned above the funnel opening so that water will drip into the funnel. After the burette holder is attached, the burette is filled with deionized water using a squeeze bottle. For this test, we will transfer 20 milliliters of water to the burette. Note that the bottom of the meniscus should be on the 20 milliliter scratch line. Now attach the burette to the burette holder. Note that the burette has a stopcock. The stopcock allows a small amount of water to pass by. This is the means by which we will control the amount of water that flows into the gauge. It is now time to communicate with the inside technician and let them know that the calibration will now start. The outside technician will now turn the stopcock so that the water begins to drip into the funnel. The dripping should be set to allow 7 to 10 drips per minute. After a number of drips, you should hear the tipping bucket tip. This will be an audible click that you will hear. This constitutes one tip, which should correspond to a certain amount of rainfall. At this time, communicate with the inside technician and let them know that one of the tips has commenced. The DAS should now record the rainfall. Allow 20 milliliters of water to drip into the funnel of the gauge. This should constitute a number of tips by the gauge. Once 20 milliliters have been dripped into the funnel, close the stopcock and have the inside technician record the total rainfall amount. Check the manufacturer's manual for the table that relates the number of tips to the rainfall amount. Repeat this procedure 2 more times. However, change the volume of water that is introduced into the funnel on the second and third tests. This concludes the calibration of the precipitation rainfall gauge. I invite you to read up on meteorological monitoring, and a good place to start is the EPA's QA Handbook Volume 4, Meteorological Measurements, which is on EPA's AMTIC website. The website is listed at the bottom of your screen. The EPA has also created video calibration procedures for other wind speed, direction systems, temperature, and dew point systems. You will find these videos on the AMTIC website. From all of us at EPA's Office of Air Quality Planning and Standards, thank you for viewing this video.